Alright, so this is the second last lesson in the patterns and textures series. So this is actually part 1 of the patterns and texture series. Part 2 is going to be mostly dealing with VDB. So all of the stuff that we've done, but just applying it to VDB, and then making like organic structures with VDB, and then also using the patterns to create like mechanical structures with VDB. So that's going to be part 2. But as far as like just using all the patterns and textures to do like random stuff, this is part 1. Okay, so this is the second last lesson in that. And what we're going to take a look at is how to mirror noise maps. Okay, so this is roughly what we're going to end up with. So this is a height field, so we'll eventually work on a height field. But yeah, let's get started. Okay, so what I'm going to do is we'll just create a height field. So the reason I use a height field and instead of using like a standard piece of geometry is because height fields are volumes and they're resolution free. So you get a preview faster, and then you can just convert it to polygons later. Okay, so what I'm going to do is you don't need to keep the size at 1000 by 1000. You can actually make it smaller. So if I make it, let's say 1 by 1, the problem that happens is because the grid spacing is too high, the object actually just disappears. Okay, so what you need to do is get the grid spacing down to something like 0.01. And if that is not enough, then yeah, okay, we're seeing something. Let's get it 0.001. Okay, I think that should be good enough. Okay, so you can do that. The only thing is that after, like, if you make it this small, erosion and stuff is not going to work. Okay, because erosion requires like a larger scale. So you can't do that on it, but for this basic purposes, it is fine. Okay, so what I'm going to do is pretty simple. Like we've done this before. So I'll just take a height field warp and plug this in and get rid of both of these and create a bind export, and we'll call it mask. So what you can do is, let's say if I take a turbulent noise and I'll take the bounding box and plug it in, and I'll keep it to original Perlin. I'll take a fit range unclamped, make it minus 0.5 to 0.5. Let me increase the frequency a little bit. So what you can do to mirror this is we have to extract like the X and Y values from here and then feed it through a ramp to mirror it, like what we've done with bitmap. So effectively we're doing the same thing. So what you can do is take a vector to float and take ramps, and this will be mirrored. So let's say this is X, and we'll do Control C, Control V. Take the second one. This is Y, and then we can do a float to vector and just feed in the first and the second, and that should do it. But the problem is like the frequency needs to be 2 for both. So if you make it 2, you'll see that it mirrors. Okay, so if I just want to mirror in one axis, so I can just take this and plug it back in. So now you're just mirroring in the X. Or if I take the Y and plug it in, so now I'm just mirroring in the Y. So that's pretty simple. Like it doesn't really require too much. And then what I can do is I can take let's take a multiply constant, and I can take the time and we can feed it into the offset. So what we'll do is we'll offset the Z, okay, because the X and Y will just make them move. So we'll offset the Z. That will give us like an animation. So we can take a float to vector, and this comes into the last one, and that goes into offset. Okay, and if we press play, you'll get this. So what you can do is we can try to take like a fit range after this, and just like you can try to, like if you want to do like a Rorschach kind of a effect, so you can do that. So yeah, so it's pretty neat, like what you can do with this. Okay, now if you want to do more fancy stuff with this, let's feed it in through a unified noise. Okay, so let's take a unified noise. We'll take a unified noise static, and instead of float to vector, we'll need a float to vector 4. Okay, so this comes into position, and let's feed the noise map there, and I'll feed this into offset. So what we can do is we can take, let's change this to Worley Manhattan, and what I can do is I can try to increase like the standard FBM, and let's give it a little more. Okay, let's do one thing. Let's just turn this off. I'll increase the frequency to 4. Let's play this and see what we're getting. There you go. So you can get some, or let's make it about 2. Yeah, so you can try like a bunch of things. We can try to do like the last one. You can try to do like Chebyshev is nice for these kind of things. See, and what I can do is let me just take this and make it 0.0006. Okay, no, I think 0.001 is fine for now. Okay, now one of the things you can do to get more interesting patterns is we can keep the frequency to 1, and let me just adjust this. And what I can do is I can take a lattice warp, okay, and get the lattice warp to 2, see, and get the frequency to about 3, and there you go. So this is excellent for doing mechanical patterns. You get like really cool fancy stuff with this. So you can try to do Manhattan. That isn't bad either. See. Now here's something else we can do. Like let's take this and we can slow it down a little, so it's not as fast. But what I can also try is this stuff that we're merging. I can take a transform matrix and we'll plug it in over here. Push that into this position, and I can try to rotate it. So let's say if I make it 45 degrees over there, see, so you can actually like try to rotate this and get different patterns. So if you want to do something like what's it called, like a kaleidoscope. Okay, so what I can do is, let's say if I duplicate this, except I need like a float to vector. Let's just plug that in to the Z axis, except that we want it we want the rotations to be faster, right? So we'll do about 20 per frame and plug that into rotation. So what you'll get is this, see. Now if you want the patterns to be like fairly hard, then you can try to adjust this, which is a decent enough way to do it. See, so now you'll get like like fairly rigid patterns. Or another thing you can do is you can try to do like a round to integer, and what that will do is it'll take everything below 0.5 and make it 0, and everything above 0.5 and make it 1. So that will give you like different, that will give you like an absolutely hard result out of it. Or as I said, like you can do it either ways. We can also just take this and like come this way, and this is also a perfectly usable method. See, so you can adjust it and see how much you want. If you want to do different levels, then what we can do is we can try to take like 2 of these. So Control C, Control V. Let's take this one, and I'll make it, yeah, let's do this. Okay, so let's say these are the high ones and these will be the low, and I can take a fit range and I'll adjust this value to 0.5. So this is slightly like less, and I can take an add. I can add these together and then clamp them. So what you should get is C. So you'll get like, two sets of values. Or if you want, then you can always just take a second unified noise and do a completely different structure. So I can just take this and plug that in, and okay, we need to offset it. So what you'll have to do is you'll have to duplicate this as well. So Control C, Control V, and this comes in here. What I'll do is I'll just offset the X. Yeah. So you'll get like, two completely different sets of values coming in. And then I can, because we're in height fields, you can do a couple of interesting, like we can blur it slightly. That will be nice. So we can just take a height field mask blur and plug it in. Make it 0.01, maybe lesser. And then I can take a remap. So take a height field remap, and we can do compute range. Okay, that's weird. Sorry, mask. Type in mask over there. And then what I can do is I can try to, you can sort of like try and do some layering here. See, so what you'll get is if you zoom in closer, see we're getting like a layer over there, like that. So we can use the blur and create like, layer patterns out of it. Like if we remove this, you should see a difference. See, so this is like this, and then if we have the blur, we get like, a little more interesting pattern out of it. And then I can just take a pattern and plug in mask and height. Let's make it 0.1. I'll change this to ramp. Size is 1. Yeah. And 0.02. Yeah, like if I zoom out, see you get some nice, sort of intricate ornate designs on the whole thing. We can try to up the resolution now. So let's try to make it 0.005. Yeah, that's pretty cool. And then I can clear it. And then I can just turn it into a polygonal geometry. So we can do convert height field, and this will be pretty dense overall. Like how much is this? Yeah, about 4 million polygons. But yeah, you get some nice details out of it. Like that's the whole. I think if you're doing something like this, simple motion graphics and things like that, and you just want to create like this complex ornate design, you can use this. So see, because of that mask and remap, we get some nice details here. Like if I remove that, it won't be bad, but you don't get that stepping. You see, you just get like these straight lines, which are fine, but then because of the height field blur, you get more interesting designs out of the whole thing. Okay, so just to sort of give you an idea of what I did, because I uploaded that on Twitter, is I took this whole thing and I converted it to height field. I did an extrude. Yeah, hold on a second. I just need to up the resolution. And I did like a mesh sharpen on the whole thing just to sharpen up everything. It's about 4 or 5 million polygons. It takes a little bit of time to calculate. And then what I did was I packed it so it becomes like a packed object, and I created like a box out of it. I can't play it back because the geometry count is too heavy. So basically what I did was I just did a mirror like top and bottom, and then one rotation this way, one rotation that way, and then just merge it together. And then I just I rendered this through Octane, but the material isn't anything complicated. Like I turned on packed geometry instancing so that Octane will sort of recognize those as instances. And in the material, it's just what I have is like just a dirt map. So I'm merging like two dirt maps. One is concave and one is convex. Let me just hit a render and so we can see it. Yeah, so that's pretty much what I have. So if I just go through the material, which isn't really very complicated, like I have two curvature maps. Like let me just disconnect everything. Okay, so I'm just going to press Y and disconnect everything. Okay, and let me get rid of the bloom and glare that I'm getting. So okay, so what I have is I have one curvature map which is generating that, and I have another curvature map which is, you know, just the edges. Like it's really fine. Like if I zoom in over here, you should be able to see it. See, there you go. You know, so it's just picking up the edges. Like if I adjust the radius, so it just picks up the edges. Okay, and then what I've done is, let me just go back to the first one. Is I have a gradient which is, I'm just sort of, you know, squashing it in so the blur goes away. Okay, so it's just a black and white gradient which just does that, you know, so it's like the blending goes away. And then that feeds into three more gradients. So this is color, and this is metalness, and this is roughness. And so this is the base color from the first one and the second one. This actually looks pretty cool. And then I add them together. So you get like this nice little, you know, like orange edge to the whole thing. And then this is the metalness. And the reason why it's turning green is because I have like a little bit of film width on it. So if it's 0, then it's like, you know, that's the basic color. But I gave it a little bit of film width so that it, you know, turns a little more sort of copperish, like, you know, old copper. So it looks a little more, you know, old and ornate. And then this is the roughness. Yeah, so that's pretty much it. Like it's not overly complex. And if I switch on full reload and if I change the frame, I should get an update. It'll take a few seconds because the geometry count is pretty high, right? Like the geometry count is close to about, you know, 5 or 6 million on one side, but it's still, the rest is instance, but it's still like a single block of, you know, 6 million polygons. Yeah, so there you go. The rendering doesn't take too long. Okay, let me just make it bigger. But yeah, there it is. That's the whole thing. All right, so the next chapter will be the last one in this series, and we'll take a look at you know, more sort of mechanical structures, but we'll also use a little bit of the trigonometric functions, okay, just to sort of add more detail onto the whole thing. Okay, so that's what we'll take a look at in the final lesson.